Hi, in this video, I'm going to present a blockchain-enabled prototype for requirements traceability in interorganizational software projects. The goal of this prototype is to use blockchain as a secure repository to store software artifacts that are created and changed by distributed stakeholders throughout the software development lifecycle. For the implementation of the prototype, we use Arganet, which is a collaborative peer-to-peer network that ensures the protection and secure transfer of digital assets of any type. In our case study, we consider requirements as tokens that are created and updated in a collaborative manner by the stakeholders who share a secret key. These tokens and operations on them are certified by trusted certifiers that are part of the network. Each token generates a signed blockchain ledger that enables the verification of its provenance, integrity, evolution, and history. The blockchain data structure used by our application is presented in this figure. First, we create a project token, which consists of the following fields: the token code, the domain of the project name, the password of the token, and additional information regarding the project. Each token consists of a set of children requirement tokens, which contain the token code, the project token code that points to the project token, the password of the token, the domain version description, the short name of the requirement, the timestamp of when the requirement was created and when it was modified, the contributor, so who performed a specific operation on the requirement token, the flex, which can be implemented or tested, the source code files, and the test cases. The emission of the requirement token generates the first block number one, which is composed of the following elements: metadata, which can be the universal ID. It consists of 26 characters as a combination of timestamp and randomness, the parent signatures or the previous block signatures, the token content, which is the content of the fields that I previously mentioned of the requirement token, the next signers. So these are the signers that are going to sign by using their private key on the hash of the next block, and the current signatures. The consequent blocks have the same structure as block number one. However, they do not store the whole token content, but only the token content changes. Any first block needs a genesis block, which is provided by the other parties of the network randomly. This structure allows stakeholders of the software development lifecycle to keep track of what, when, how, by whom requirements were created, changed, implemented, and tested in a trustworthy and transparent manner. Now I'm going to demonstrate the application by using a few examples. The logging view of our application shows that there are four logical users: the requirements manager, developer, tester, and customer. The prototype relies on the assumption that these users are located in distributed settings and they do not trust each other. However, they have to collaborate with each other for the development of a large scale software project. Of course, this is a simplified version of the software development lifecycle. First, I'm going to log in as a requirements manager. This is the requirements manager's view. We can see all the attributes of the requirement token, and we can see that by clicking the create button, we can create a new project as a requirements manager. The project has been successfully created and the token code has been assigned automatically from the blockchain. Now that the project has been created, we can create requirements by using the create option of the radio button requirement. Let's try to create a few requirements. By clicking the accept button, we store this requirement on the blockchain and we create the requirement token. The requirement is successfully added, so we can see that the token ID has been automatically assigned. The contributor name, we can see the version, description, short name, the current status which is created, and the timestamp of when the requirement was created. The requirements manager can also update an existing requirement by clicking the update option of the radio button requirement. For instance, we can try to update this requirement, view lab. We update the version, description, and the short name. By clicking the accept button, the token change will be stored on the blockchain. Requirement is successfully updated. We can see that the status changed from created to changed. We can see the timestamp of when the requirement was changed, and the updated version, description, short name, also the contributor who performed this change. Now I try to log in as a developer. First, I retrieve the list of requirements of this project. The developer can upload a source code file for each requirement. For instance, we can upload the source code for this requirement. By clicking the accept button, we store the requirement token change. The requirement was successfully updated. We can see that there are several changes that occurred. First, the current status is implemented from created that was previously. We can see that the implemented field is updated as well, and also we can see the source code file field that is updated. Now we are going to log in as a tester. We retrieved the list of requirements for this project. We can see that the tester has is allowed to perform two operations, with uploading the test case file and also deciding whether the test result is passed or failed for each requirement. We will try to upload the file and also to insert the past test result. The accept button is going to update to update the requirement token and also to store the test case file and the test result on the blockchain. The requirement was successfully updated. We can see that the status changed from implemented to tested. We can also see that the tested field is updated because the test result was passed. And you can also see the test case file, which is uploaded. Now I'm going to log in as a customer. The customer is allowed to retrieve the list of requirements for this project. The list of requirements is retrieved from the blockchain, and now the customer can see the last changes on each requirement token. Also, the customer is allowed to keep track of the life cycle of each requirement token by double-clicking on the requirement. So the customer can keep track in this way of what requirement was created, when the requirement was created, the version of the requirement, when the requirement was changed, who performed this specific change, if the requirement was implemented, tested, and also the source code files and test case files. So the customer is going to have an overview of the entire life cycle of each requirement token.